So I think my workaround here is going to be to present in the browser.
Okay, sounds good.
Yeah, I'm just going to
we're
quickly,
just,
I know we're live, but is anyone else on right now?
Yep, people are slowly
Okay.
trickling in here. We got about 30 people on the call right now.
Okay. I won't give it a test then. Well,
Sure, it'll be okay.
All right. So I'm just going to quickly override that onto, yeah, this one here. If I hit full screen on that, are we good to go?
Yep, that looks great.
Perfect.
Alrighty, are you seeing my full presentation view?
Yep, that's what's up.
Alrighty, I think we'll get started here. So we've got about 31 people on the call today, which is great. So just like to say hello and welcome everyone to today's webinar. My name is Thomas Harrington, and I am an agri-environmental specialist with Perennia Food and Agriculture. As host, it's my privilege to welcome you to today's webinar. I want to thank you all for taking the time to join us here today. We'll start with just a few Zoom housekeeping items first. All participants will have their audio and video turned off to prevent background noise during the webinar. You are encouraged to ask questions, so please use the Q&A feature at the bottom of your screen. These will be monitored during the presentation by our team members and verbally asked. You can also use the chat function, but this will be visible to all participants to comment and respond. Since it's a little bit smaller group here today than some of our other webinars, you can also request to be unmuted, and one of the team members can unmute you and you can verbally ask a question too, if that's easier. Also, before we begin, I would like to give a brief introduction to the new Nova Scotia Agri-Environmental Program, or AEP. The Agri-Environmental Program is a partnership between the Nova Scotia Federation of Agriculture, the Nova Scotia Department of Agriculture, and Perennia Food and Agriculture. This program combines environmental components from each of these organizations, building on their individual strengths. The AEP provides comprehensive and relevant information to help reduce environmental risk on farm, increase public trust, and expand market access through 4 foundational pillars. The program is funded through the Canadian Agricultural Partnership, which is part of a commitment by federal, provincial, and territorial governments to promote productivity and profitability for the agriculture sector. Please learn more about this program by going to the new website, www.nsaep.ca. This webinar series is an initiative of this new Nova Scotia Agri-Environmental Program. I'd also like to comment about the pesticide continuing education points that are available through this webinar. All participants who attend the duration of the webinar will be eligible to receive the points. Since it's a virtual session and this is a little bit different format than a typical in-person session, the way it's going to work is you will receive a link after this session, and you will click on this link and input your pesticide number and your name and contact information, and you will be auto-generated a receipt. We'll also have a list of all the attendees, and if you have any issues with this, we can also manually report your or generate your receipt and send that into Environment as well. So this session will count for 1 hour in application technology category. And again, if you have any issues with this this process after the fact, just feel free to send me an email with your pesticide number and we can manually take care of that as well. So for today's panel, I will be presenting the bulk of the information on the calibration session. I've been with Perennia for about 7 or 8 months now. I started back last summer, working as part of this new Agri-Environmental Program. And previous to that, I've got experience working in precision agriculture and operating sprayers and quite a few different types of equipment. Also joining me here today is Patrick Hennessey, who is a PhD candidate with Dalhousie University. I'll introduce Patrick a bit later on in the session. Patrick is going to give us a bit of a look forward, I would say, in sprayer technology to some of the new things that are coming down the pipeline in terms of innovations and that sort of thing. Also joining me here today is Trevor Davison from the Environmental Farm Plan. Trevor's going to be helping us out with the Q&A session at the end. And also, if you want to direct any questions to Trevor during the presentation, if you have any issues, technical issues or things like that, send him a note as well, and he should be able to help you out. So a brief overview of where we're going today. Here's the agenda. We're going to start out with why Calibrate, how do rate controllers work, different types of controllers, system components and setup, calibrations, troubleshooting, some of the advanced features that are available with rate controllers. And then we're also going to look ahead to sprayer tech, which is going to be an interesting portion, and this is going to be presented by Patrick. And then we'll have a question and answer period at the end. So this session is intended to be very practical. We've got a good representation of producers on here as well. So this session is meant to give you some tools you can take back to your farm or your operation to work with your sprayers and your rate controllers to make sure you're applying properly. I just want to mention that this is focused at field sprayers. We're not going to be covering orchard or air blast sprayers, as that calibration process is quite a bit different. So this is really targeted towards boom sprayers essentially. So why do we want to calibrate a rate controller? Or why should you need to calibrate a rate controller is a question you might be asking. Well, if you've ever been in the situation where you're out spraying and your rate controller says that your tank is empty, but you actually still have 100 gallons left in the tank, maybe that's a good idea, or maybe that's a good indication you might need to do a calibration. Or perhaps your tank is empty, but your rate controller says that you should be able to do 5 more acres. Obviously, something is not quite right there. Also, if you're getting over and under application alarms all the time when, or your rate controller can't quite hold the rate that it's selected to achieve, then this might be another indication. Or why does my pressure always go so high when I'm in the field spraying? These might be a couple indications that you might want to check out the calibrations on your rate controller. Also, from an IPM perspective, we want to ensure that the product is being applied at the correct rate. Just because your rate controller says that you're applying at a certain rate, that doesn't necessarily mean that's what's coming out of the boom or the nozzles. So we want to check that and make sure that it's actually reading properly. You want to maximize your pest control efficacy, reducing crop injury, and reducing environmental contamination risk. So basically, we want to make sure that your readings from your rate controller are correct and you're not over or under applying your product. So what is a spray rate controller? Basically what it is, it's a device that allows the operator to select a desired application rate. Today we're talking about liquid rate controllers, but they can also be dry rate controllers as well on fertilizer spreaders, or it can also be on seeders or anything. So rate controllers can be quite versatile and control any number of products. So how do they work? They compensate for changes in your travel speed by adjusting the flow rate supplied to your nozzles. And they generally have some sort of user interface that allows the operator to view information or make changes to the controller. They may also be integrated with section control switches. So this formula here is essentially what a spray rate controller is doing inside of the controller box. This is a calculation that it's working off of. And I'm going to refer back to this a number of times throughout this presentation. So if you're ever having issues with your rate controller or things aren't quite working properly, think back to this formula, and it might give you some tips of where to look and where your problems might be with your rate controller. And I'll go into more detail on this later. So they come in all different shapes and sizes. This is a 3-point hitch mounted sprayer that is set up with a rate controller. They can be set up on large self-propelled sprayers like this Haggy. They can be on tow behind sprayers. They can be on smaller self-propelled sprayers like the Solder spray coupe. And they can even set up on small sprayers like this one on the side-by-side. So how do they work? So I mentioned before, basically there's some sort of display and interface. There's going to be a speed source. You're going to have something that's actually going to monitor your flow, which is usually going to be a flow meter, and you're going to have some sort of flow control device. So these function together to monitor speed, flow rate, and they utilize some sort of control mechanism to adjust flow. And flow is controlled either by increasing the speed of the pump or by increasing flow to the boom with a throttling valve. And it's important to remember that more pressure is going to equal more flow in these types of systems. There's newer types of systems that use other methods to control flow, and I'm not sure Patrick might touch on those. Some of the newer sprayers have pulsing nozzles to adjust flow, but the most common in the conventional type of rate control system uses a pressure type flow control. And there's that formula again that we're going to refer back to. The question you might have is, if I have a rate controller, does this mean I don't need to change my nozzles? If I have one set of nozzles, shouldn't the rate controller make adjustments for me? And the answer is that the rate controller is only capable of supplying a relatively minor adjustments to flow rate. And most nozzles are designed to perform in really just a small range of pressures. So it's important to match your nozzle and your pressure to your normal travel speed. And you should really only be relying on your rate controller to maintain your application rate due to smaller infield speed variations, such as if you're going from a rough section of the field to a smoother section of the field, or if there's hills, and when you're starting and stopping on the ends of passes when you need to speed up or slow down your machine. So there's a little bit of math behind why this happens. So here's a formula here that looks a little bit complicated, but basically, if you double your travel speed, this means you're going to need to increase your pressure 4 times to reach the desired flow rate. So if you increase your speed from 5 miles per hour to 10 miles per hour, and your spray pressure was 20 PSI in order to reach that desired flow, the flow rate controller is going to command the system to open up the throttling valve or speed up the pump, and your pressure is going to have to go to 80 PSI to reach that desired flow. So that's fine when you start with a lower pressure, but what if you're spraying at 5 miles per hour and your spray pressure was at 40 PSI? If you double your travel speed, then all of a sudden you're going to have 160 PSI to reach the needed flow, which is definitely much higher than what nozzles are typically designed to work for, and you might have issues with the plumbing on your boom, or your pump might just not be able to reach those pressures. And here's just another example based on a nozzle chart from a high pro ultra low drift nozzle. So here again, if you were spraying at whatever speed and your pressure was 20 PSI and you doubled your application speed, you're going to go to 80 PSI, and you can see on the droplet size chart, you're going to have a huge decrease in droplet size based on that pressure increase. So 20 to 80 PSI might be within the working range of your nozzle, but if you're started at 40 PSI and you doubled your travel speed, you're going to be well beyond what the rated working pressure is for that nozzle. So this is important when it comes to what product you're applying, because many products on the label will state a minimum droplet size that you're allowed to spray with this product. So for example, the Velpar label states do not apply with spray droplets any smaller than the coarse classification. So that's something to keep in mind. So you might be tempted in your fields to speed up to increase your productivity, but you need to really watch your pressure because the flow, your rate controller doesn't have any, it doesn't know what the effective pressure is going to be on your nozzle. So it's going to say, if you speed up, I need more flow, and it's going to increase your operating pressure, and your nozzle, your droplet size is definitely going to increase. So that's something to keep in mind of what your actually desired droplet size is and what your operating pressure should be with that nozzle that you have equipped. So The moral of the story is to make sure you match your nozzle with your intended travel speed and rely on your rate controller just for smaller corrections. So there's many different types of rate controllers, and I'm going to attempt to describe both types. So essentially there's two. The first one I'm going to start with is a standalone type rate controller. This is the simpler type. I just grabbed a screenshot from a microtrack system, but so basically what this is the controller mounts inside the cab. This device is actually a display and a rate controller built into one. Usually there's some sort of user interface and some calibrations and things that you can do. It might also be tied into some master boom switches and things like that. So essentially it's not tied into the tractor in any way except for grabbing power. This is another one. This is a Raven rate controller that's fairly common. So basically this controller, it's quite easy to move around, but it's limited in maybe some of the advanced features that it can do where it's not actually tied into your tractor at all. But the advantage is that you can put it on any tractor basically as long as it has a power source. So what are some of the disadvantages of this type of system? Well, if every controller if every implement has its own controller, you might end up with some clutter in the cab. This is definitely an extreme situation, but I've seen some potato planters where you might have at least 3, maybe 4 different types of standalone control boxes in your controller. So it can definitely clutter up the cab with excess wiring and that sort of thing. So if you just have a simple rate controller on a 3-point hitch sprayer, it might not be too bad. But if you have like a liquid application system on a planter and that sort of thing, you can definitely take up some cab real estate with those different types of controllers. So I'm going to focus now on the second type of rate controller, which is an isobus type system. The advantage of this is that most newer tractors now have some sort of display in the cab, such as this. This is a Fendt cab with their display on the armrest. So the idea here is if you already have a display in the cab, why should you need a second one? You've got a perfectly good working display here that's integrated into your tractor. All the controls are on here as well. So that's where isobus comes in. So isobus has been around since the early 2000s, and it's a universal communication and design standard. And the whole idea is to allow agricultural implements and tractors of different makes and models to communicate together. And there's the Agriculture Industry Electronics Foundation, which is a nonprofit organization that works to establish compatibility between these types of systems. It's definitely not sprayers. It's really targeted at all agricultural implements. So the whole idea is if you have a display and you plug in your implement to the back of the tractor that's going to populate on the display, it's going to look the same no matter which tractor it's hooked up to. So this is an example of another implement hooked onto the Fendt display. Maybe you plug in a fertilizer spreader to the back of that tractor and it's going to populate on the display as well. And the advantage of these systems are that tractors and implements are functioning as one unit. You don't have a separate display or separate control box. And the rate controller itself is usually mounted back on the sprayer, so you're not taking up as much room in the cab. Other advantages include you can integrate your implement with your GPS. So this gives you options for coverage mapping, section control, and data recording. And it also reduces, as I said before, excess wiring and clutter in the cab. And there can actually be some reduced costs with these types of systems where you're not actually buying a whole nother display and control box. And you're utilizing some of the equipment you might already have. Definitely the downside of this is that it needs to be with a relatively new tractor to be compatible. So if you've got a mixed fleet where you're moving implements around a lot from older machines to newer machines, this might not be the solution for you. But if you're looking at upgrading down the road and flipping your fleet around a bit to newer machines, this is a really good option to consider. So as I mentioned, here's a Trimble rate controller. Basically, it's a black computer controller box that would mount back on the sprayer somewhere. And then when you hook on the sprayer to your tractor, there's going to be a large isobus plug at the back of the machine that you're going to plug into, and it will automatically populate on the display here. So definitely a lot simpler and a lot tidier in the cab for sure. And here's a look at some other isobus controller units. So I just grabbed a bunch of different options and types of displays. So there's Raven controllers, there's Ag Leader, GPS displays, all different types that you can mix and match. That being said, there definitely are some circumstances where things might not be compatible. So there's a really great online tool that's hosted by the AEF, the not-for-profit organization I mentioned before. So they manage this compatibility check tool. So if you're looking at going with an isobus rate controller and you want to know if it's going to be compatible with your tractor, you can come on here. Or if you're getting a new GPS display, you want to know if it's going to be compatible with your existing system, you can come on here and you can type, pick from all different types of products, different software versions, all that sort of thing. So here's one example where I picked a Raven rate controller and I picked a newer Case IH tractor. And what it does is it will basically compares the compatibility of these two different systems, and where it's highlighted in blue, that's where they match up, and that means that these systems are compatible. So when I punch these together, it told me that they will communicate as a user terminal. So when I plug in the rate controller, it'll populate on the case display. It tells me that it says TC base. That means that it has basic task controlling capabilities so that the case display will actually document what I'm applying. And then the third one that's highlighted on the rate controller means that there's the ability to turn sections on and off with section control based on GPS coverage and desired overlap. So that's one way to check if you're looking at different products and different machines. You can check and see what your capabilities are going to be when they're combined together. So in summary, like I said before, the basic components required are going to be some sort of display, whether that's an isobus type display or a standalone display. You're going to need a speed source, you're going to need a flow meter, and some sort of flow control. And there's that formula again that I mentioned. I'm just going to break right here and just check if there's any questions coming in. Nope. Alrighty, so feel free to, you can punch them in anytime, but we'll also have a Q&A session at the end. So now we're going to dive into some of the display readings off of the different systems. And so they're obviously going to be a little bit different depending on brand and depending if it's a standalone type controller or an isobus controller, but basically they're all quite similar. So this is that MicroTrack spray rate controller as well. I'm just going to use as an example. So with this dial, you can manually select different options and it will display here on the LCD display. So you can view as applied rate, tank volume, flow rate, speed, target rate. There's a volume counter that you can use, an area counter, as well as distance counters. So you can get this particular display will give you 3 different counters for each. So you could have like a season total, a daily total, and maybe like a field total as well. And quite common is also to have a productivity reading as well, so to tell you how many acres you're covering per hour, which can help you for time estimates on how long it might take you to complete a field and that sort of thing. They're also quite often integrated with section switches on the rate controller as well. So on the top of this unit, you've got 3 different section control switches. Here's a look at this Raven unit, and it's quite similar, just laid out a little bit differently. So you have, you've got your speed, distance, volume, area, as applied rate, productivity, flow rate, all these sorts of things. So they're pretty similar across the different units. They just might be laid out a little bit differently. This is a look at a John Deere rate controller system, and you can see it's definitely a little bit more user-friendly. It's kind of laid out as a graphical interface as opposed to the LCD type display, but it gives you really the same information. It gives you as applied rate, target rate, tank volume, speed, boom pressure, productivity, and your different sections. So the difference with these types of units is that they're really configurable. So if you want to see different things laid out in different ways, it's really easy to configure this or pick different readings depending on what you want to see to monitor your operation. And I circled here, really the best place you're going to want to be keeping an eye on is your as applied rate versus your target rate. That's going to be the first place you're going to see if you start having issues. So if your target rate is 12 gallons an acre, and all of a sudden your as applied rate is significantly different than that, that's going to indicate that you might have some sort of problem. So the rate controller should be capable of holding your rate. So if it's not able to keep that rate for whatever reason, that's an indication you're going to want to start taking a look at what your issues might be. So for measuring speed, there's basically three options. You can have a wheel or drive shaft sensor. You can have a GPS speed sensor or a radar speed sensor. And no matter which type of sensor you have, the rate controller is generally going to understand your speed and pulses of current. So what this means is that each of these speed sources are going to have a speed cal number or speed calibration number. And it's what actually allows the rate controller to translate these pulses into speed. So for example, how many pulses per second correspond to how many miles per hour you are traveling. So a GPS speed sensor actually gives you true ground speed. And as I mentioned before, it's going to be pre-calibrated with a known calibration number. Basically, you'll enter this number into your controller. One thing to note with isobus systems is if you have a GPS sensor on your tractor somewhere, it's generally going to auto pull that GPS speed from your tractor. And if you don't have a GPS sensor, it might pull wheel speed from the tractor. Through harnessing, it's also possible to pull simulated radar speed from these sensors as well. So for example, if you have a rate controller on an older type planter that needs a radar source, it is possible to get an add-on wiring harness to pull a simulated radar speed from these different types of GPS sensors. A radar speed sensor also gives you true ground speed. These are definitely becoming less common since the popularity of GPS. And basically it works like a GPS speed gun. It sends out a pulse of radio frequency from the sensor and it calculates the delay it takes to return back to the sensor, and that gives you calculated speed. So these can be quite large and they may be mounted on the tractor or implement. And if a tractor has a GPS receiver, it's generally redundant to have a radar sensor. These were found a lot more commonly on self-propelled sprayers before GPS became a bit more popular. I would say the less common type of speed sensor that we see now is a wheel or drive shaft speed sensor. So the basically way this works is with a series of plates or magnets, and there's a proximity sensor, and as the wheel or drive shaft turns, it generates a pulse of current, and and that's going to give you your speed cal or calibration number. One thing to note is these can be quite inaccurate as they don't take into account wheel slippage. So if you have really loose soil conditions, or if you've got a lot of slippage from different types of soil conditions, or the way your machine is set up, then you're not going to actually get a true ground speed reading with these. So for measuring flow, there's primarily two types of flow meters available. There's a turbine or a magnetic type sensors. And similar to the speed sensors, as flow moves through these, it generates a pulse or a signal. And this is just like a common wiring diagram that you might see on a typical flow meter. So you're going to power, ground, and then your signal, which is going to be your pulse that's generated as the flow meter turns. So this flow cal number is what's, it's the value that actually converts these known, this pulses into a known volume. And these are factory calibrated with water. And for example, this flow meter has a cal number of 1,878 pulses per gallon, or 496 pulses per liter. So when you get your rate controller and you get it set up, that's going to give you a really good starting point for calibrating your flow meter. What might cause this number to change is if you've got a solution with a slightly different density, or if your flow meter starts to accumulate a little bit of debris, or if it gets maybe worn a little bit. This number might actually need to be fine-tuned and adjusted, and we'll go through that process later. And this is a standard turbine flow meter. There's a small turbine inside the boom, and as the flow passes through the boom, the turbine spins, and the speed at which this spins is going to be proportional to the liquid volume flow through the boom. As I mentioned, it's very important to keep this clean, as any sort of debris is actually going to affect how fast the turbine spins, and that's going to affect your flow cal numbers. So you can clean them with soapy water. It's going to depend on the manufacturer's recommendations, but they might also recommend using something like a brake parts cleaner or something like that. The newer type of flow meter that we're seeing on the market now is a magnetic flow meter. And so it's actually, if you look through it, there's no moving parts inside. And the way it works is it generates a magnetic field around your pipe or your boom, and it generates a voltage that changes as the flow changes through it. So some of the advantages of this is they generally don't need to be calibrated once they're set up, and they don't really require much cleaning other to make sure there's not accumulation inside the plumbing. But the main downside is they're definitely at a higher cost than the regular flow meter. So for controlling flow, there's two types of flow controls as well. I would say the most common is a servo valve or a throttling type valve. And the way this works is it opens and closes to regulate flow to the boom. And it's quite simple. It's commanded to open by the rate controller based on your speed and flow meter reading. So if you speed up, your servo is going to open up to allow more flow to go to the boom, and it's going to increase your pressure. These are usually found on something like a Turbine sprayer or a 3-point Hitch sprayer, where your RPM is going to be constant. Like your pump is hooked up to your PTO, so you can't easily vary that RPM of your pump to control your flow. So it uses this electric servo valve instead. The other type of system that's usually found on self-propelled sprayers is a PWM, or pulse width modulation valve, on the pump. And so this works differently than a throttling valve, where the pump itself is actually varying its RPM based on the commands from the flow controller. So if you speed up, what it does is it commands more hydraulic flow to the pump, and the pump itself actually speeds up and sends more flow to the boom. So two different types of systems. The previous one is more so on 3-point Hitch and Turbine sprayers. The other one is more generally found on self-propelled systems. The other thing I wanted to touch up on is how to actually set up the controller, which is really important. When you get your controller, if you buy it from a dealer, it's important to check and make sure that it's been set up properly in the display or on the actual controller box itself. So we've covered flow rate and we've covered speed. So this section is going to cover actually setting up your boom width in the controller. So the important questions to ask are, how many sections do you have? How many nozzles do you have per section? And it's important to check every section and not assume that they're going to be equal. And what's your nozzle spacing? And really the best way to do this is to get out a pen and paper and draw a diagram of how your boom is actually set up on your sprayer. So you can see in this example, the sections are not all necessarily the same size. So as I mentioned, How many sections? Maybe you've got 3 sections. Maybe it's a small sprayer and you've got 4 nozzles per section. What's your nozzle spacing? Maybe it's at 20 inches. So you get out your pen and paper, you draw out your diagram, and you calculate out your widths. And you can input this information into the controller. So there's a special case. So what if you've got a bedded or a row crop, and you've got perhaps a 100-foot boom with a 20-inch nozzle spacing? This might be great for spraying something like wheat, but you want to spray potatoes with it, but your potatoes are at 3-foot row spacing. So if you've got a 100-foot boom, that actually is going to cover 33 1/3 rows. So obviously you can't drive down a part row, so you're going to have to make a decision. Are you going to spray at 33 rows and potentially have an overlap, or maybe do you spray at 34 rows and have a miss? And some people might decide to go that route, and I would say more commonly a producer might make an adjustment to the boom setup. Maybe they add on an extra nozzle, or maybe you turn off the outside nozzle so that you're not overlapping as much. And the main thing to consider is that any modifications you make to your boom and your boom setup or your boom spacing is that needs to be reflected in your rate controller so that it knows exactly how wide your boom is. Here's just an example from a John Deere rate controller that it, when you set up your working width, you can set up your actual track spacing in your row width, and it's going to automatically calculate your overlap. So if you made an adjustment and you changed your working width, you're going to want to actually come in and change all that information in your controller to make sure that it's going to be accurate. All right, let's get into calibrations. So we're going to start with speed calibrations. So with a GPS speed sensor, generally these should not need to be calibrated. There's not really anything in them to lose a calibration. So what you're going to do is if you're using a standalone type rate controller, you can look up the correct speed cal number for your GPS sensor, and you should just be able to input this into your rate controller. And using this correct speed cal number for your controller is going to be critical. And this number is usually displayed in inches or centimeters per pulse. So with this speed sensor, this is one from Ag Express, but there's a lot of different types available. And the speed cal number on this one is 58.9 pulses per miles per hour. So you just put that into your controller, and you should be good to go. You shouldn't need to do any further speed calibrations with that. Calibrating a wheel speed sensor is definitely a bit trickier. There's more of a process to it. The usual way it's done is to measure out a specific distance, for example, 400 feet. You're going to drive this distance and compare your distance traveled displayed in the controller versus the actual distance measured on the ground. And it's really important with this process to make sure your conditions match your infield conditions as much as possible. Where I mentioned before that it doesn't take into account wheel slip or soil conditions. So if you calibrate this on gravel or on pavement and you have 0 wheel slip essentially, and you go to a field and all of a sudden you've got 2, 3, or 4% wheel slip, obviously your calibration is going to be off. And yeah, like you mentioned there, just make sure you do this in the field. Have your tractor weighted up the same that you would, maybe have half a tank to give you an average of what your weight's going to be on your machine, and make sure your tire pressures are set up correctly. One thing to mention is be aware of whether you're going to use 4-wheel drive. This can change your calibrations as well. Generally, the wheel sensors would be mounted on the rear axle, but if for some reason you had one on the front axle and you hit your 4-wheel drive button, your front tires are going to be turning slightly faster than your rear wheels, and that's going to affect your calibration as well. So the third type of speed sensor is your radar sensor, and it really is calibrated similarly to the way that a wheel sensor is going to be calibrated. You're going to measure out a known distance in the field, and you're going to drive this distance. Compare the measured value to what is shown in your rate controller display. And if your values differ significantly, obviously you're going to need to do the calibration, and you should repeat the calibration a couple of times to make sure that it was successful. One thing to mention about radar speed sensors is that their position is very critical. So it's their angle and the height off the ground is essential to their calibration. So anytime something changes, so if you're adjusting your tire pressure or something like that, that's going to significantly impact the height of the sensor. You're going to need to redo your calibration as well, because it's sending out a pulse to the ground and measuring how long it takes to get back to the sensor. So all those angles are important in that setup. And another thing to consider with a radar sensor is that windy conditions can cause inaccuracy. So if it's really windy out and you're spraying in a tall crop and the crop is moving around a lot, sometimes that can cause your speed readings to be a little bit inconsistent. So now we'll look at calibrating your flow meter. And I've outlined 3 basic methods to do it. They've all got different advantages to them. I would say the best method really is to do this method 1. It's definitely the most time consuming, and it could actually be difficult or perhaps impractical depending on how your plumbing is set up. But in most of the flow, the rate controller setup guides, they recommend this method. So what you should do is disconnect the main boom line at some point after your flow meter. And you're going to place your plumbing into a large container that you can actually collect or to measure or weigh your water or your your solution coming out. Ideally, you should obviously be doing your calibrations with water. So you're going to fill up your tank, start the pump, and set your flow counter to 0. Collect at least 100 gallons if possible, and then compare your collected volume with the total volume displayed on your rate controller. If there's at least 2 or 3% difference, you're going to want to adjust your flow cal number. So most units will let you do this automatically. So you could adjust your collected, adjust your displayed volume so it matches your collected volume, and that will give you a new flow cal number that you can record and save for later use. And generally, increasing your flow meter calibration number is what you should do if not enough product is being actually applied versus what was actually being measured, and decrease your flow cal number if too much product is actually being applied. And here's a bit of a diagram of how you might do it. So here's a typical setup on like a 3-point hitch sprayer. Your plumbing is coming from your pump. It's going to go through your flow meter, through a servo valve to your section valves. So what you could do for this calibration 1 is disconnect it here somewhere after the flow meter, 0 everything in your controller, put it into some sort of container that you can collect it from, and compare your collected volume versus your measured volume on your rate controller. And if those volumes are more than 2% difference, then you should look at adjusting that cal number. So I'd say method 2 is definitely less accurate, but it could be good for a quick check, maybe at the start of your season, just to make sure everything looks good before you load up your tank with chemical. So also it's important to note, you want to make sure that your nozzles have been tested for uniformity before this. So you fill your tank with water, start the pump, and turn on your boom and run at a working pressure to prime the booms. You're going to set your controller to read total volume and set it to 0. You're going to measure flow with a measuring cup or graduated cylinder from at least 2 nozzles per section. Take the average volume across the entire boom, and then multiply this by the total nozzles to give you an estimated total flow. So I made a diagram here too to maybe explain this a bit better. So you turn on your sprayer, make sure everything's zeroed and your boom is primed. Collect flow into at least 2 per section, two measuring cups per section. So in this example, maybe we collected from 6 cups. We got 4.8 liters per cup, and this gives us 178 liters estimated total. And if our rate controller said it was 180 liters that came out of the boom, this is less than 2% difference, so we're probably good to go to hit the field. So like I said, this is like a very quick and easy way to check your calibration. I wouldn't necessarily use this to fine tune your rate controller. And your method 3, I would say you can use this. I'm going to call this the full tank method for fine tuning. So what you should do is fill your tank as accurately as possible, right to the top, right to the full value. Spray out until your pressure just begins to drop. So if you're watching your spray pressure gauge, as soon as your dial just starts to drop, shut everything down. Stop your sprayer immediately. And then here you can actually measure your total volume sprayed to your actual sprayed volume. So this is a way to simulate your calibration using a full spray tank. So you can actually do this in the field on the go. Like I said, I wouldn't use this for major adjustments to your flow cal number, but this is a way that you can fine tune it so that your rate controller is actually going to read 0 when your tank is empty. So I'm going to go over a few troubleshooting tips. So if your pressure is always too high, or you're under applying and you're getting under applying alarms, you could likely need to slow down, or perhaps you need to get a larger nozzle size. So what this could mean is your rate controller's commanding your flow valve or your pump to supply more flow, but it's just not able to get it out through those nozzles because they're perhaps too small. If you're constantly over applying, maybe you need to travel a little bit faster, or maybe you need smaller nozzles. So perhaps your pressure is always really low and you're getting these over application alarms. Maybe your nozzles are just too big. The third thing on this list is if your rate is always erratic and it's bouncing around all over the place, you could need to adjust your valve response time. So especially on those throttling valves, if they're trying to make adjustments too quickly, you could have an erratic rate. So maybe you need to slow down the response time, or maybe it's not responding fast enough. You could also check your speed source and your flow meter just to make sure that your wiring and all that is intact. I've definitely seen this if your wiring is, you have like a chafed wire that's maybe just slightly loose or something, and then that could cause this erratic rate. And another thing I wanted to mention is that these factory flow cal numbers are generally for water only. So if you're adding liquid fertilizers to tanks, such as 28% UAN, this is definitely going to affect your density of your liquid, and you're going to want to redo your factory flow cal, or redo your flow cal numbers as the factory numbers for water only. So if you're doing a lot of liquid fertilizer applications, this is something to keep in mind too. It's definitely going to affect your flow cal number. So just before I hand it over to Patrick, I want to go over a few of the advanced features and newer things that you can get with rate controllers today. So if you have a newer type rate controller that's integrated via Isobus, there's really cool things you can do with coverage mapping. Anyone who has ever messed around with a foam marker and them not working, and it can definitely be an exercise in frustration. Coverage mapping is a really handy tool to have. You can see exactly where you have and haven't applied. It's also great if you ever get rained out, or if you have technical issues with your machine. You can stop your application, come back to the field, and resume exactly where you left off with your application. You can also do things like automatic overlap control, because your system is tied in. Your rate controller is tied into your GPS system. It actually knows where you've previously sprayed and where you haven't sprayed. So the system can command your boom sections on and off based on your previously sprayed areas. One thing to mention is that you can change these settings a lot, whether you want 0% overlap of your sections all the way up to more than 100% overlap. And this is going to depend on what you're spraying. I've seen issues before where people say, I don't want to overlap. I want to make sure I use as little product as possible. But that leads to issues like triangle misses, especially if you've got like an angled field or something like that, where as soon as the tip of that section hits a previously sprayed zone, it's going to shut off and you're going to potentially have a big miss in your field. So you can fine tune that. It's definitely going to depend on which product you're applying. So herbicides, for example, you might not want to leave any triangle misses, but depending if you're doing a fungicide or something like that, depending on the product, you may be okay with some small misses in the field. And the other thing you can integrate in with this is field mapping. So if you have a grass waterway in your field that you definitely don't want to spray, you can automate that with section control. So if you go around in the springtime and you map out your waterways and your field boundaries, you can set these up in the sprayer so that when the boom hits them, the sections will automatically shut off. So that can speed up efficiency. So if you've got a big field with a number of waterways through it, it can be tough to be manually shutting those sections on and off to make sure you don't spray them. So that can be a way to automate that and speed up your field efficiency by just allowing you to travel straight from one end of the field to the other and let the system look after that process. I just want to mention as well documentation and record keeping. So an IsoBus rate controller should give you lots of options for documentation. So when I say documentation, that's basically your spray records, any information you want to input about your products. So this can be weather conditions, your product, your rates, what crop you're spraying, that sort of thing. So this can really reduce paper records that can be easily lost. They can usually be exported off the machine by a USB stick quite easily, which you can wirelessly link to your applications as well, depending on how new your system is and what type of communication it has. At the very least, having those records on a USB stick, and you can sometimes import them into like a Excel spreadsheet or some other type of farm management software, can be a really powerful thing to have. And newer systems, you can sometimes even view these in real time on your web browser or via phone app. I would say many of the newer systems have this capability, and it works really well. And so I mentioned USB stick for transferring data. Most of the newer machines, such as John Deere, Case, and Trimble, have some sort of wireless syncing capabilities. They've all got different names and different technologies, but essentially what they do is they work via a cell connection and some sort of modem that's mounted in the tractor. And this is going to automatically sync your application data to your phone or an app that you can view on the internet. And you can access all of your application maps in real time, essentially, or to be able to go and look at them at the end of the day and see your coverage and field totals and all that sort of thing. And one thing I want to mention is that a lot of these systems can actually be integrated with your invoicing software for and also for generating reports and spray records and that sort of thing. So one of the best ones I think right now is the Farm Credit Canada Ag Expert software. It's integrated with the John Deere software. I know they're working with a few of the other equipment providers as well. And so what that does is kind of gives you an end-to-end solution from your tractor cab right through to your accounting and reporting software on the other end. So that's pretty much what I had to cover. I feel like I went through a lot of stuff. I'm hoping there'll be some good questions. But what I would like to do now is hand it over to Patrick Hennessey. I'm really happy to have him here today with me. I kind of reached out to him about a month ago, and he seemed to be really enthusiastic and happy to help out with this presentation. So I'm really glad to have him. So Patrick he's a PhD candidate at Dalhousie, and he's under the supervision of Dr. Travis Esau. And after completing his Bachelor of Mechanical Engineering degree, he worked in custom metal fabrication. And Patrick has had a strong interest in computers and electronics since his early teens. And in 2018, he returned to Dalhousie to study the use of deep learning, which is a form of artificial intelligence for use in the wild blueberry industry. His master's thesis examined the use of deep learning for targeting and spot spraying herbicide on hair fescue and sheep sorrel in wild blueberry fields. Patrick is currently working on developing a smart sprayer which uses his technology to selectively spray herbicide on these weeds and more. Today, he'll be discussing upcoming innovations in the future of pesticide spraying. So Patrick, I'm going to stop sharing my screen and pass it over to you.
All right, thanks, Thomas. Let's just see here. How's that working out?
It's great.
All right, well, thanks for the kind introduction. Yeah, so I'm a graduate student at Dal. Some of you might know my supervisor, Dr. Travis Esau, especially if you're in the wild blueberry industry. I did an engineering degree, but essentially I'm a big computer nerd, and I'm just trying to figure out ways to make smart technology for agriculture to help improve farm sustainability. Over the past couple of years, I spent some time developing some algorithms that can detect two specific weeds in wild blueberry fields, hair fescue and sheep sorrel. And the long-term plan for that technology is to develop a smart sprayer, which uses cameras to sense the field conditions and decide whether or not herbicide, fungicide, or fertilizer should be sprayed depending on the field conditions. Yeah, and this isn't applicable just to wild blueberries. It can be used for pretty much any crop. And it's really, the whole thing is rooted in the idea of precision agriculture, which is essentially the use of technological advances to improve decision-making and crop management. There's, some other examples of this on top of the variable rate spraying are, harvesters which track yield using GPS and using UAVs to create NDVI maps to see which areas of the field need more attention or better management practices. And overall, this area of technology should help create more sustainable practices for the entire industry. And an example that we saw, just a few minutes ago was this slide in Thomas's presentation, where there's this automatic overlap control, making sure that we're not spraying too much, respraying areas that were already sprayed, or spraying areas that don't need to be managed. Specifically at Dal, our main focus is wild blueberries. But as I said, this can be applicable to a lot of other crops. We work with the University of Prince Edward Island with their engineering department, and they do a lot of work with potatoes. As well, we work with the University of Florida, and they do a lot of work with citrus fruit and strawberries. And since long before I was involved with the research, harvester efficiency for wild blueberries was a big topic at Dal. That's been improved over the past number of decades, I think, in partnership with Doug Bragg Enterprises, who manufactures a lot of the harvesters. On top of that, my supervisor, Travis Esau, started a project where he was creating a smart sprayer, which essentially turned the nozzles off and on depending on whether the field needed chemical application. And starting out, I don't know if that video is going to play or not. Let's just see here. What we'll see here is maybe not. Okay, well, we'll see the still here at least. We see these light gray boxes, and these are cameras, and essentially it sends an image back to a central computer in the cab of the tractor. And this specific algorithm is meant for fungicide applications. So you see these bare areas of the field where nothing's growing anyway. So the point of this was to avoid wasting chemical on those areas that wouldn't need it. Another application for that green detection would be weed detection, where the time of year that we spray for weeds, the weeds are often starting to green up, but the leaf foliation on the wild blueberry plants hasn't started yet. As well, John Deere See and Spray. If you're following some of the industry news, you'll see that they put out a video last month about their new See and Spray Select technology, and that uses the same idea, green detection, to see where the weeds are and spray herbicide only when there's a weed there. The issue with that, though, is that it can't really distinguish between different plants of the same color. So if there's crop foliage that's green at the same time there's green weeds, you'll be spraying herbicide on your crops. As well, if there's two weeds in your field, two species of weeds that need different chemicals for management, say you're spraying Valpar and you're there's a second type of weed in there that Valpar is not effective on, there's no point in spraying Valpar on it. You're just wasting excess chemical. So we're looking at developing smarter systems that can basically narrow in on the exact species of the weed, so you can decide when exactly it should spray. And that's sort of done with a new type of technology called deep learning. And it's a form of artificial intelligence, which uses a lot of data to train a computer to make decisions. With traditional computer programs, we specifically define what we want the computer to do. So I can say, if the computer sees green, then spray. And there's a number that's associated with the color green, or a range of numbers with a range of shades of green. But it's sort of hard to program in leaf shape. So there could be a leaf that's round with a pointed end, or maybe bladed leaves like hair fescue. And maybe, there's a different type of blade. So there's, a leaf with wide blades. And how do you write that into a computer? And that's difficult. So we kind of let the computer make the decision on its own. I show it thousands of pictures of the weed I wanted to identify, and the computer finds the patterns on its own. The last set of training used about 4,000 pictures per weed, but some testing shows we only need about 500 per weed. So we can expand this really quickly as soon as we figure out the common problems with the technology. So far for wild blueberries, we've used it for weed detection in my research, but we've also used that to classify berry ripeness. The long-term plan for that is to do yield prediction before harvest even happens. You can take a few pictures of your fields close up of the berries. It can essentially count the number of ripe and unripe berries, so you can see what your harvest yield, get an estimation for it before you go out and do the work. As well, one of my colleagues developed a debris detection system using the same technology, which can be used to help calculate shrink before you take your harvested product to the processor, like Oxford Frozen Foods. So to do this, data sets of thousands of images in a lot of different contexts. So in the upper right-hand corner, there's a few hair fescue tufts. In the upper left, we see some sheep sorrel leaves in a fairly waterlogged field after a lot of rainfall. And as well, you see in the lower right-hand corner, there's a picture with no weeds. It's important for the computer to understand when not to spray. So those images are important too. And then we go through and we label each individual weed instance. And with that, we train the algorithm, and we come out with okay. And then we get basically a computer program that can detect where the weeds are, no matter what the foliage is. So you can see those other weeds and pieces of foliage in here that are green, but it's picking up the hair fescue tufts and leaving the rest. Now, in order to do this, we typically need some high performance computing to train the AI. But as far as running it can run on pretty standard computers. So a laptop, a smartphone, even a small single board computer like what you see on the screen there. And something small like that is going to be the key going forward for smart sprayers. That's something that can process multiple cameras and make decisions based on what it sees in the field. And that's a very small device. It's only about $150. And DAL is far from the only institution that's working on this. Here's some pictures from a paper that UPEI just published a few months ago, where they're detecting lamb's quarters in potato fields. So they train their AI using images from potato fields, and they developed a prototype sprayer, which you see over here. Unfortunately, it's not working in the field quite yet. The rugged conditions make too much vibrations for the cameras. The proof of concept works in a parking lot, but the next stage for development is going to be figuring out how to dampen out those images so they're clear. As well, our colleagues at the University of Florida did the same thing for detecting Carolina geranium mixed in with strawberry plants. So that can, again, help with field management in another crop. And it's not just universities that are doing this too. AgriFac already has a sprayer which is using the same technology, where it has cameras here that are pointed ahead of the boom, and you can see where the weeds are. You can see in the still image, none of the nozzles are turned on, but up ahead, there's an instance of a weed that they're looking for. And everything in that field is a similar shade of green. And this is just a top-down view of the concept of the technology. And that's available now. I think it has been for a few years, actually. So overall, the benefit of this is going to be a reduced cost of herbicides because you're going to be using less. As well, there's going to be less time spent managing your fields because you'll have to refill your tank less often. And by using less excess chemical, there's going to be better resistance control and better long-term environmental sustainability. Yeah, and this research is really made possible because of my supervisor, Dr. Travis Esau, as well as all my co-supervisors throughout the past few years. The research teams at DAL and UPEI. Right now, we have funding from the Wild Blueberry Producers Association and My Tax Accelerates, and previously had funding for this from NSERC, the government of New Brunswick, and DBE. And those are just the references for the images if you want to look back at those later on. And yeah, that's an overview of what's happening at DAL right now.
Awesome. That's great. Thanks, Patrick. That's some really, really interesting and cool stuff happening here. So we would like to open it up now to any questions. You can type them into the Q&A panel, and or you could also request to unmute yourself, and we can do that if you want to ask your question verbally, or you can type it into the chat if that's easier too. So yeah, we'd like to welcome anyone to submit your questions. I've got a few, I guess, off the start here for you, Patrick, if you don't mind.
Oh yeah, certainly.
What are some of the main challenges with this type of technology in terms of like lighting conditions, for example? How much does that impact the camera's ability to detect different weeds? Are you limited to only certain types or times of the day because of shadows and that sort of thing? Or how much of an impact does that have on this?
Really, the algorithms are as good as the data you feed it. So as long as, like, I plan to take images in all sorts of lighting conditions. And what that does is the more robust the data set, the more varied the input data set, the better the algorithm is. So if I capture images in, shadowy conditions, then the computer learns what the leads look like in shadowy conditions. If it's a really bright day and the image might be overexposed, same thing. So as long as I do my data collection during, all hours when spraying might happen, which I plan to do, this should generalize really well.
So your system is only using ambient light, is that correct? You don't have light source in front of the boom or anything like that?
Exactly, yeah. We depending on how things work out over the next year, an extra light source might be required, but as of now, it doesn't look like it's going to be necessary.
And so these cameras, are they only using visual light? Have you done any work looking at like near infrared type cameras or any of that sort of thing?
I'm kind of leaving that off just because, those sort of cameras are more expensive. The point of the system is to be low cost enough that it pays for itself. And the easiest way to do that is use a standard RGB camera.
Okay.
Yeah.
So how easy would it be or what would be the process if you wanted to start looking at another crop or another weed, for example? Like you're looking at wild blueberries right now, obviously, but if you want to apply that to another crop, how easy is it to do that? You just need to go and gather basically a set of training images and feed that into it to get the new algorithm. Is that essentially how it works?
That's essentially how it works. Yeah. So in May, I'm going to go out with the sprayer with the cameras attached and not spray. Just take a whole bunch of new images so I can detect on top of these two weeds. I'm going to work on getting hawkweed, goldenrod, and moss, adding that to the algorithm. And it's just going to be a matter of driving the sprayer with the cameras on it through the field and then extracting still images from the video that it takes. After that, we're going to use a high performance computer to train this. And that could take a couple of days. And then, of course, if there's a lot of tweaks you can do to the training methods. I didn't go too deep into the technical side of what needs to be done. But it's something that if anyone who's computer savvy can pick up. One of the barriers for training is probably the cost of the training computer. these computers probably start at, 5 to 10,000 and go up from there. If that's too much of an input cost, though, you can rent processing time from providers like Google and Amazon. They'll let you use their high performance servers for a set number of hours for, anywhere from 5 cents to $1 an hour, depending on what sort of power you want.
And how much is it affected by the background imagery? Like obviously the weed, if you're targeting weeds, the weed size and shape and color and all that is one thing, but obviously blueberries are changing a lot in whether it's a sprout year or crop year, and the background basically that you're comparing the weed to. Is there a point where it gets very difficult or impossible to detect, or can you comment on that? How, what's the impact of basically the background noise to the ability to detect weeds?
Yeah, as long as the training data has that background noise too, it generalizes fine. Agri-Fac actually has a really great video showing what their cameras are seeing while it sprays, and you can see like the sorrel they're trying to spray is really similar to the crop foliage, but it's still able to pick between the two and know what to spray.
Okay, right on.
Yeah.
Just saw there's one question come in here. Let's go take a look at that. The question is, my sprayer is a mist blaster boom overhead that has no nozzles, but has 2 discs for the sorted round holes of different sizes. Can this be sufficient for proper calibration and mist droplets? I would say, I guess right off, I don't have a lot of experience with mist blowers per se. They are definitely more challenging to calibrate. Basically, as long as you can collect what the output is from the rate controller somehow. So this, maybe you actually disconnect the line from your where it's actually going into the airstream, and you can just collect it into a container and actually verify what's coming out of the rate controller that way. That might be a way that you could actually collect what's coming out, because obviously it's much more difficult when it's entering the airstream to do that. But yeah, like I said, I don't have a ton of experience with mist blowers. They can be a whole nother beast to try and calibrate, especially in orchards and things when you're kind of you're dealing with a 3D crop as opposed to a 2-dimensional crop. There's things like tree row volume and things like that. But yeah, basically, as long as with your mist blower, like for example, if you're using it for blueberries, if you know what your track spacing is in the field, whether it's 40 feet or 50 feet, and you know what your estimated flow is coming out of the rate controller, then you should be able to do a calibration that way. Christmas trees. Yeah, it's like I said, it is tough with trees where you start dealing with the 3D crop, and sometimes even the recommended rates can be based on tree row volume, which it gets a little bit more complicated that way. I would say check out Michelle Cortons, our tree fruit specialist, just did a podcast on rate controllers and air blast sprayers with Jason DeVoe from Sprayers 101. I would say he did a great job of explaining calibrations and things like that, and the issues that you see with air blast sprayers. So I would definitely check that out if you have a chance. And I think that's on the brand new website. And if you want the link to it, just let me know. Any other questions?
Interject. There is a comment in the chat session there from Jeff Orr. I don't know if you.
Nope, I didn't see that one. I guess I can pose this one to you, Patrick, maybe. Mm-hmm. This is from Jeff Orr. How long do you think before the smart sprayer technology might be available? And secondly, do you see this as likely to focus only on one weed type per pass? This would be viable with fescue, but maybe not some of the more minor weeds.
Yeah, so as far as availability, like I showed, there's a slide there. Agri-Fac already has theirs commercially available. For large crops, John Deere is definitely working on it in the background. That See and Spray that they are selling now is actually developed by Blue River, who they bought out. And if you look at Blue River's promotional material from 2018 and 19, they're using the same sort of deep learning AI type stuff. So I'm expecting that John Deere will have it on the market in the next few years. As far as my research, I'm expecting to have this ready in about 4 years. I just started my PhD and there's a lot more testing I want to do on it. As far as crops per pass, really sort of the information flow is going to be seeing what weeds are there and then defining which weeds should be sprayed. So I can detect, as many different classes of weeds per pass as need be. So it could be looking for fescue and sheep sorrel, hawkweed, whatever. It could pick up, 10 or 20 or 30 different species of weeds with one single algorithm. But then we're really going to have to define which of those weeds are worth spraying during that pass based on what your tank mix is. So I guess in short answer, yes, we can really target more than one weed at a time, but it's really going to end up being what weeds do we want to target.
Yeah, and I think that highlights the importance of the research that you guys are doing locally in wild blueberries, where maybe the technology is available, but it's obviously corn and soybeans, and a lot of those crops are the first, I would say, first on the draw of getting that technology and getting it suited towards them. So I think that highlights the importance of why we need to be doing this research here in wild blueberries, where we have the resources here and the personnel and the fields and all that sort of thing. It's great to have this research being done here. Got another comment here. Is it best to select a nozzle which produces your desired droplet size in the middle of its pressure operating range to accommodate wider ranges in travel speed, or your desired droplet at the lowest rated pressure? I would say generally it's better to start with your travel speed. So if you look at a field, what's my fastest travel speed that I can usually comfortably travel, and use that as your starting point. So if you can, in a blueberry field, for example, maybe you can get up to 5 miles an hour on a relatively flat field. Use that as your base to picking your target droplet size. I would say in most cases, you're much more likely to need to slow down into a field due to like a water course or a rough patch or something like that than to speed up. So you're better off to try and look at your highest speed, pick your pressure associated with that higher speed, rather than the other way around, so that you have more range on the lower end of that to keep your droplets in the right range. Yeah, just another comment there that, yeah, it's important to have specific data for the weed pressures that we're seeing in our region. So for sure, I can see that's a huge project, and there's always new weeds that are either having challenges or taking off in different areas too. So I can see it would be a challenge to keep the system updated with all of those training data sets. And obviously different regions, even in the province and the area, are going to have different types of pressures and different weeds that might be more applicable. So yeah, I can see it's a challenge for you, Patrick, to get out at all different times of the day, whether it's dusk or early morning, and try and get all different types of data. So
yeah, and really I'm just trying to work out all the kinks in the system, so as soon as something new pops up or a new scenario pops up, we can just take a bunch of pictures and retrain it and hopefully have a new algorithm ready in a week.
Yeah, exactly.
So that takes a lot more trial and error over the next few years.
For sure, I can only imagine. All righty, I'll do one last call for questions before we wrap up. All right, so just to review the pesticide continuing education points, I know a lot of you are here to get some of those points and hopefully learn some new information as well. But this afternoon, I'm going to go through the participant list, and I'll send you all an email with a link. And what you'll do is click on this link, and it will ask you to put in your name and your pesticide license number, and as well as your email address. And what this will do is it will auto-generate you a receipt that you can use to submit to Nova Scotia Environment when you go to renew your license. We will also have a copy of that as well if there's any issues. And I would say if you have any trouble with this process, just send me an email, and just give me your license number, and I can auto report that for you too if you're having any issues there. This is what the form will look like when you click on the link. So you see it's pretty simple. Just put in your name, email address, your physical address as well. That's a requirement from Environment that we record that, and put in your pesticide certification number. And once you hit add to cart, it gives you a receipt. It's similar to if you're making a purchase, I guess, but there's obviously no cost. You just hit add to cart and hit purchase, and then you get a receipt emailed back to you with all the information on the course and the number of credits and all that you're going to receive from the session today. If there's any certified crop advisors on the call, this session also will give you continuing education points under that program too. They've got a pretty slick app that you can just scan this QR code with your camera on your phone, and it will automatically give you those CEU points. Again, if you have any issues, just send me an email, and we can get those. We can get that manually registered for you as well. So I'd like to thank you all for joining us. We had a great turnout and some good questions. This is part of a larger Agri-Environmental webinar series. So the next session on April 27th is going to be about surface water management and the Nova Scotia Water Withdrawal Program. We're going to have a guest presenter from Nova Scotia Environment on the call to talk about that. So anyone who is doing irrigation or any type of water withdrawals in large volumes, you might want to check this out. The guest is going to go through and walk you through the whole process of everything you need to know from a regulatory perspective, and hopefully give you the tools you need to navigate that process smoothly. In the email I'm going to send out, there's also going to be a link to a survey. If you've got any comments or suggestions or critiques or anything like that, feel free to send those along as well. It'd be greatly appreciated. This is a link to, this is my email address at the bottom, and you can find that also on the Perennia website. If you want to check it out later, just go to perennia.ca. This recording will be available on the Perennia YouTube channel probably in the next day or so if you want to go back and review any of that information. Just because Nova Scotia environment requirements, only the live participants can actually get the points. So if you if you want to go back and check out that later just to review some information, that's great. But only participants of this live session will get the link to actually record the points. So I'd like to thank you all again today. This is a great turnout, and hope to see you again soon, sometime in person. Thanks for joining us.